This is the first video for Chapter 3. In Chapter 3, we will be investigating the idea of independence. And our first lesson in Chapter 3, Lesson 3.1, is Does the hot hand exist in sports? To a statistician, the idea of a hot hand means that an athlete's or a team's ability to win goes up following a win. If the hot hand does not really exist, then that means that each attempt performed by an athlete or a team is independent because the athlete's ability to be successful is the same following a successful performance or an unsuccessful performance. In other words, if your chance of winning a game was 70%, it would stay 70% whether you won the game before or you lost the game before. If a team has a hot hand, then that means their chance of winning goes up with each win that they have. To investigate this, if we were in class, we would play a game of rock, scissors, paper. And if you have someone at home that you can play a game with, you can try this at home yourself. Anyway, what we're going to do is try 15 games of rock, paper, scissors. And I'm going to record my wins and losses only in this chart in your notes. And we're going to ignore any ties. So, for example, if you play rock, paper, scissors at home and you throw scissors and your opponent throws scissors, you will just ignore that game. You're going to play 15 times or enough times as it takes until you have 15 wins or losses. Last time I played rock, paper, scissors, this was the result of the games that I had. And notice there, I started off with a win and then I lost. And then I had what kind of looked like a streak of 6 wins in a row right here in the middle. Later on, I had a shorter streak of three wins in a row. We don't count 2 in a row as a streak typically, so anything 3 and above would be considered a streak at this point. But anyway, my longest streak during this set of games was 6 wins in a row. We would like to test the claim that I have a hot hand in rock, paper, scissors. So we want to see if we have evidence that this is a hot hand. So I'm going to use the length of the streak as our test statistic to test the following hypotheses. Now we're going to write the null hypothesis a little bit differently than we did in Chapter 2. And in Chapter 3, our null hypothesis is going to be that the outcomes of the athlete or the team's performances are independent. So in this case, we would say that my outcomes of my rock, paper, scissors games are independent. And as the alternative, we'll say that I had a hot hand during these games of rock, paper, scissors. You could also say that I am a streaky rock, paper, scissors player. Now we're going to conduct a simulation to see if getting 6 wins in a row is easy to do or if I actually have a hot hand. And we're going to use playing cards again for our simulation. Now, if you don't have playing cards at home, you can use index cards or little slips of paper, and you're going to write wins and losses on those based on the results of my 15 games. Now, overall, I had 11 wins and 4 losses. So you can either write win on 11 cards and loss on 4, or if you want to use a deck of playing cards, we're going to use 11 black cards to represent the 11 wins and 4 red cards to represent the losses. Now, what we're going to do is shuffle them out and lay them across the table and record the results in our notes. So I'll show you a couple of examples of what that might look like. All right, so let's say I shuffle my cards and I deal them out. Remember that each red represents a loss and each black one represents a win. And I don't have space to do all 11 next to each other, so I'm continuing down into the second row. Notice in that top row, I had a streak of 3 wins in a row, and then a loss, and then 2 wins and a loss. And then in the bottom row, I actually have a streak of 5 wins in a row. Oh, and there's one last card. There's the 11th card. In your notes, then, you would put a dot at 5 because my longest streak was 5 in a row. Now you can shuffle the cards and you can deal those out again. And you can repeat this many, many times to see what typical results would look like. So here's a second set of 11 cards. And notice in this one, I have 3 in a row right at the beginning. Then I've got some wins and losses. And then I have another set of 3 in the row, counting this 4 here and the 10 and the king that came after it. So I actually have 2 sets of 3 wins in a row. But my longest streak is 3, and we're really not considering how many streaks there are. We're looking for the longest streak. So on the dot plot, then, I would put a dot at 3. Now, I used an applet to repeat this many times. In fact, I did it 100 times, and here's what the results look like. So you can see that getting a streak of 4 or 5 or 6 or even 7 in a row happens fairly often. It's not very often that we get a streak of 9 in a row. It is possible that maybe you could get 10 in a row, although it didn't happen at all when I did this simulation. The values that we're interested in to calculate our p-value for our test is how many times did we get a streak that was as long as mine or more extreme, which in this case would be longer. Because if 6 in a row makes me suspicious that I might be a streaky player, then an even longer streak like 7, 8, or 9 would be even more convincing evidence. So I would need to count up all of the dots in this simulation that are at 6 or above. And as it turns out of those 100 dots, we ended up with 48 that were at 6 or more. So 48 dots out of 100 gives us a p-value of 48%. Then we can make our conclusion. 48% is much, much larger than 5%. So our conclusion would be that we would fail to reject the null hypothesis. We do not have good evidence that I am a streaky rock, paper, scissors player, or in other words, we don't have good evidence that I have a hot hand. Now, cold streaks work the same way because if a team has a greater chance of winning after a win, that also means that they have a greater chance of losing following a loss. So when we're looking for streaks, we really want to consider both hot streaks and cold streaks and look for whichever one of those might be the longest. And we're going to look at the Detroit Lions for an example of cold streaks. This is their results from their 2015 season. And in that season, they had 7 wins and 9 losses. Notice they started off the season with 5 losses in a row. And then they kind of had some wins and losses. And then they had a couple of short streaks with 3 wins in a row here and 3 wins in a row over here. But we want to know if that cold streak at the beginning of the season is evidence that they were a streaky team in 2015. Like we wrote our hypotheses before, our null hypothesis will be that the outcomes of their games are independent. And this time, to write our alternative, we're going to say that the Lions were a streaky team in 2015. Generally, we don't use the term hot hand when we're referring to a cold streak. So if you say that they were streaky, that kind of covers both types of streaks. Now, if you're going to do this simulation at home, you would want to get 7 black cards and 9 red cards because their record for the season was 7 and 9. And you would conduct this the same way that you did the rock, paper, scissors simulation, where you would take all 16 cards, shuffle them up and deal them out, and look for which streak was the longest. Now, in this case, remember, you're looking for hot and cold streaks. So you might get a hot streak of 4 and a cold streak of 6, then your longest streak would be 6. But on some cases, you might end up with a longer hot streak than a cold streak, and that's okay. Now, I again used an applet to conduct this simulation just for time, and these are the results that I got. And the dot plot in your notes only goes down to 3. And I actually had a couple of instances where the longest streak that I got was 2. And like I mentioned, typically we don't consider 2 in a row as a streak, but you can see that with 7 and 9, it's pretty uncommon for them to get a long list of wins or losses in a row. Now, the Lions in this particular season started off with a cold streak of 5. So 5 would be our test statistic. And when we estimate our p-value, we would need to count up the number of dots that are at 5 or greater. Now, this time I only did 50 simulations, and if I count up those dots, there are 10 there. When we calculate our p-value then, our p-value would be 10 out of 50. Before we do that, let's write down the answer to the next question, which is, what is your test statistic? The test statistic was the length of their longest streak, which was 5. The p-value then is 10 out of 50, which is 20%. And again, that value is much larger than 5, so we would make a similar conclusion. We would fail to reject our null hypothesis. That means we do not have good evidence that the Lions were a streaky team in 2015. All right, please do the homework from section 3.1 in your assignment packet.